Hi, this is Jeff Stevens again from Salsion. So we're going to pick up right where we left off before by looking at the quality control parameters, the EDCF plots. So these are just a way to give you a rough idea of how comparable the data sets are. As you can see here, what you're looking for is a good overlap between the lines. You can see depending on where you are in the region, the lines may be a bit different. One thing to bear in mind is this could be a real difference. It may be a sample-to-sample variation, but because we have a couple of lupus patients that look like they're off, that's something to keep in mind. Those are our LE samples. So an important thing to bear in mind is this could be real, but it's just something I think to consider as you go forward. So now we're going to move on to the actual auto-gating section. And from that we click on plots. That'll open up the auto-gating. And what you see is essentially a set of layers, the base view, the compensation view, and the bi-exponential view, which we've done in the previous set of exercises in the first tutorial. The comp view is the compensation applied to the raw data, which is the base view. The bi-exponential transformation is then applied on top of that to the compensation data. And that gives you your readout. You can actually export this all as a picture if you want to use it in presentations. And as you'll see, it gives you a nice view of the gating strategy. So the first place we start is by choosing our population. And so by default, it starts on your bi-exponential transformed and compensated population. In this case, since this is a T-cell panel, we're going to look at CD3 versus time in a dot plot. And I just know from experience that a lymph gate actually works really nicely here. So we'll talk a little bit more about some of the parameters in some of the subsequent tutorials, but as you'll see, the scaling factor, which we'll visualize a little bit later, just gives you a rough idea of how big your gate is, and you'll see that later. So what we want to do is bias the gate towards CD3 cells, in this case T cells, and the scaling factor is going to help us do that. The BW factor allows us a bit more fine granularity, which again I'll speak to more in some of the subsequent tutorials. But once you hit the apply button, you'll give the computer a second. You see the progress bar down below is letting you know, that the program's not crashed, that you're just waiting on things to progress. And what's going to happen is everything's going to update here very shortly. And you'll see that in your view, as well as in the parent population. So this is actually showing you the raw data. So by default, the negative population is what shows up first. So we're going to go in and change that to the positive population, which you're going to see appear as soon as this refreshes. One important thing to keep in mind is we don't downsample, and by that I don't mean we don't remove any events. This is the pure data that you're getting from whatever instrument you happen to be running. So you're seeing everything, not like most other software that's out there. So if it seems a little slow, it's because you're looking at big files and big data sets. So as a T-cell immunologist, what I'm going to do is actually really zoom in on the population I'm interested in, which is CD4 positive T cells. And so whatever you select as your y-axis parameter is typically going to be your focus point. And you can see that from the red writing down there at the bottom, which shows you what your primary gating parameter is. So again, we're going to choose another lymph gate. The lymph gate is going to allow us to hone in on those CD4 positive cells at the expense of CD8 cells. This is a great gate if you have two fairly dominant populations in a pool, and you want to really zoom in on one as opposed to the other. Part of the process of learning this program is understanding on your own, I think, to some extent. You have to do some empirical analysis to see what gating strategies work the best for you. And in this case, I know that lymphocyte gate is going to work great for CD4 cells. For some of the more subtle populations, we'll talk about that subsequently, there's some other gating strategies you might want to apply when you have a smear of cells. But as we wait for this to refresh, you'll see what's going to happen is it's going to very nicely pull out those CD4 positive cells. We'll go back and switch so we can zoom in on those guys. And then what we want to show you, everybody always asks about, well, because we're not drawing little circles and squares around things, how do you know what is in your gate and what's not? So this is literally what has been gated. But what we're going to do is do something that we call a layer. So we're going to add an additional layer, which is going to show you just exactly, first of all, what your filter, which is your pre-selection scaling factor, looks like, and also the cells that were excluded from the gate. So in this case, we're going to look at our negative population. We're going to overlay a filter. You can change the layer color to whatever you like. We have several different colors. And by applying that, you'll see very briefly, it shows you exactly what you've gated on and exactly what's not. So in this case, the blue dots are the cells that are excluded from the gate, and the ellipse that's outlined in red shows you exactly what you've gated in on, which correlates with the pre-selection scaling, the statistical scaling factor is exactly the cells that you've gated in on. So this shows you exactly what you've done. Okay, so from this point, what we'll do is try a different type of gating analysis, something perhaps slightly more subtle. Again, the BW factor is something that we'll discuss in more detail coming up. Essentially, the default values tend to work fairly well if you're working with these types of populations, whether it be B cells, T cells, NK cells, or granulocytes, whatever. We tend to stick with the default numbers, but you can play with those, and that's something that you pick up empirically. So now again, we're going to select our parent population. Excuse me, I picked the wrong gate. We're going to take our layer off just to make it less confusing. And again, now you can see exactly the cells we've gated on. So for the next set of gating parameters, we're going to select a subset of CD4 cells. In this case, we're going to look at a subset of CD4 cells, CD183, which is CXCR3, versus CD196, which is CCR6. We're going to use a different type of gate this time called a k-means filter. And to do that, we're just going to go up to the Action to Apply window, the drop down there. And that's a really straightforward gate which essentially defines those populations on the basis of essentially as if they were a bimodal population. In this case they're not, but you'll see where we're going with this in just a second. So if we apply a k-means filter, no parameters to use here, just click on the Apply button. You're going to split it up into a nice 183 positive and 183 negative population. And this works really great for things that are perhaps a little bit more subtle. And again, this is something that you may have to play with in the beginning a little bit while you set up your template. The template is something that we're going to get into in the next tutorial. So if we go ahead and apply that filter, again, the primary gating parameter is listed on top in red, and that's going to be your y-axis. If we apply that, you'll see the image go gray as the computer is doing its processing. And now you see that we've really done a nice job of pulling out those 183 positive cells. And we can really see that if we apply the layer, let's give it a second to refresh, and we apply the 183 negative cells, and you may have to adjust the axes. Sometimes you do, sometimes not. Here we're going to just to allow you to see where the negative cells lie. Yeah, there you go. So that shows you really nicely. Again, the blue dots are the cells you've excluded from the gate. In this case, there's no filter because the k-means filter, you don't have the same kind of filtering mechanism. You're not using an ellipse or anything like that. Okay. You can also play with the point sizes if you like. In this case, the populations are pretty abundant, but sometimes for very rare populations, it's helpful to play with the point size. You can do that on both the negative gate as well, and by that I mean the gate down below, and you can do that as well as on the positive population. So, and oftentimes what I like to do with this sort of a group is sort of flip them around and use the same filter. So in this case, you can see our primary gating parameter is CD196 positive cells. So you're going to divide those up, essentially the cells that are positive on the y-axis, using the same approach. and you'll see you'll get a very nice split in 196 positive, 19 negative. So now you're looking at double positive cells. If we go back down, well, excuse me, if we select the negatives, you can see the negatives are now the cells that are in the contour, and the positives are the blue dots. It just depends on how you set up your image. We can apply or take the layer off in this case, and that will allow us to see just the 183 positive, 196 negative cells. So in terms of imaging, for presentations, the easiest thing to do is you can simply drag and drop these files, which show up as PNG files, which you can easily import into a number of different presentation or photograph, things like Adobe Photoshop, PowerPoint. You can also save the files PDF if that's your preference. And that's also true of the layering. So with the layering, you can do exactly the same thing. If you apply the layer, you can save the plot as a PDF, or just simply, like we're doing here, drag and drop it, and that's very easily imported into your whatever presentation or imaging application you happen to be using. So as you can see, our auto gating structure has been updated, and with that, we'll move it to the next tutorial.